Multiple points is the points of the curve where more than one branch of the curve is passing through that point. For example, if this is the point and if one branch is passing through the same curve, that is the two branches here are passing through this point, it may happen that there is another branch is also there which passing through this point. Suppose the curve is like this. Then this point P, it's called the multiple points. So if f of xy is a curve in R2, and if you want to say this point P is the multiple points of this curve f of xy, then more than one branch of the curve passing through this point P, then P is called the multiple point. Now after this multiple point, we have the definition of the double point. The double point means the exactly two branch of the curve passing through that point, then it's called the double point. For example, this type of curve or this type. There is another classification of this, it's called the ordinary point. The ordinary points of the curve f of xy equal to 0, where this f of xy is a continuous function and fx and fy are exist, and if fx is not equal to 0 and fy is not equal to 0, all those points where fx and fy are not equal to 0, all that points are called the ordinary points. The next one is the singular points. The another classification is the singular point. A singular points, the definition is the same. If you have a curve f of xy equal to 0 and fx and fy are exist, and this fx equal to 0 and fy equal to 0, all the points where simultaneously both this fx and fy are 0, then that point is called the singular point. So we have a few definitions here we have concluded. Let us revise that. The first one is a multiple point. Multiple points means the point where the more than one branch of the curve passing through that point is called the multiple point. That is a double point. Double point is two branch of the curve is passing through the point, then it is called a double point. The ordinary point means this f of xy is a curve where f of xy is a continuous function. If the fx and fy exist and simultaneously this fx is not equal to 0 and fy is not equal to 0, all those points are called the ordinary points. Singular points means the same condition, but fx and fy simultaneously they are 0, then it is called the singular point. So these are the definition of, or I can say classification of the points for the curve. Now there is a classification of the double points, that is our objective of this video lecture. The classification of the double points are the three types. The first one is the node. Node means double point, that means that there are two branches of the curve which passing through the same point. A node means there will be a branch. At this point you will get the two different tangents. Two different and real tangents you will get. Then it is called the node. For example, this is the one of the example of a node, you can say. At this point P, you will have a two tangent. The first tangent is this along this branch. Another tangent is along to this branch. So there is a two tangent at this point P you will get. That's why this point P is called the node. The another classification is the cusp. The cusp is this type of figure you will have. There is a one graph, and at this point P you will have a cusp where you will have two equal tangents and real tangents. Two equal and real tangents. For both the branch you will have two equal tangents. That means for this branch you will have, this is the tangent, and for this branch also you have the same tangent. The last one is the isolated point where at the point P you will have two different and complex tangents. So if you have two different and complex tangents, that means the complex tangents are there, then we can say that point is isolated point. There is another name of this isolated point. It's also known as a conjugate point. So these are the classification of the double point is there. In this video lecture, if you have any given curve of the form f of xy equal to 0, then how to classify, how to find out that which type of double point it is. So that is our objective, and we are going to discuss about this example and what is the procedure to conclude or classify this double point. So let us first see the steps that how to find out the double point of the curve. First of all, you have given this f of xy equal to 0, which is the equation in R2, or I can say it is a curve in R2, such that this fx and fy are exist. Then we are applying the following steps. The first one is first find what is fx and fy and solve this equation, that is fx is equal to 0 and fy equal to 0. Suppose that solution of this fx is equal to 0 and fy equal to 0 is nothing but the AB is the solution of this equation. Then the second step, you have to check whether this point AB is lies on this curve or not. So check if AB lies on the curve. If yes, then point AB is the double point. If you have that is the thing, then the point AB is called the double point. So the double point means fx and fy is 0 and if it is lies on that curve. Third step is to find R, that is f xx at the point AB, s which is f xy at the point AB, and t fyy at the point AB. The fourth step is to check whether there is a fourth step, part A, if s square minus rt is positive, then AB is a node. Second one, if s square minus rt is negative, then AB is isolated point. And the C part, that is if this s square minus rt is equal to 0, then AB is the cusp. So again, the node means it is of this type of figure, this cusp, that means it is of this type. So this is the point P, which is called the node, and that is the point AB that we have here. So this is the way to check whether the given equation or given curve has a double point as well as which type of double point it is. So let us now solve some examples related to it. So the example is the same, find the double point of the function as well as calculate which type of double point it is. So the function is given is f of xy is equal to x cube plus y cube minus 3xy. So the first question is to calculate what is fx, that is the first step, is 3x square minus 3ay. Fy you will have 3y square minus 3ax. So now you have to solve this equation, fx is equal to 0 and fy equal to 0, which gives you 3x square minus 3ay equal to 0 and 3y square minus 3ax equal to 0. So this will implies x square is equal to ay and y square is equal to ax. Now we need to solve these two equations. So if I substitute the value of y, or I can make the square here, so that is x power 4 is equal to a square y power square. After substitute this value of y square here, then we can get x raised to 4 is equal to a square ax. So that will imply x is common out, x cube minus a cube equal to 0, and that will give you x is equal to 0 or x cube minus a cube equal to 0. And this will give you two solutions, that is x is equal to 0 or x minus a equal to 0. Because what is the reason that the a cube minus b cube, we know that it is a minus b, a square plus ab plus b square. So according to that we have x square plus ax plus a square is another factor, but this is never 0, because this x and a, both of them are a real number. They are, and this equation will give you a complex solution. So that's why that is not possible. So only two value of x is possible, that is x is 0 and x is equal to a. Since you have this equation y square is equal to a y, you will have y square equal to a y ax. So that will give you y square equal to a into 0. So y is 0. And for this one, for the x is equal to a, it gives you y square is equal to a into a. So that's why y square is equal to a square, and that will give you y equal to plus or minus a. So what are the possibilities of this double point? The first is 0, 0, because when x is 0, you will have the value of y is 0. The another one is a, and the last one is a minus a. So these are the double points you have if these points are on the given curve. So let us recall what is our curve. Our curve is x cube plus y cube minus 3xy. So we have to substitute this point. So first of all, 0, 0 point is on the curve. So this is on the curve. Let us check for this one. The curve is x cube minus 3, x cube plus y cube minus 3axy. So that will imply a cube plus a cube minus 3a, comma a, that is 3a cube, which is equal to minus a cube, which is not equal to 0. So that's why this is not on the curve. Let us check for this one, that is a comma minus a. So that's why this will give you, so for the point a comma minus a, we have a cube minus 3 into a minus a. So that will be, and that is also not equal to 0. So therefore this is also not on the curve. So hence these 2 points are not on the curve, so therefore they are not the double points. So only the double point is 0, 0. Now we need to classify whether this 0, 0 point is the node, cusp or isolated point. So for that I need to calculate what is r. R is nothing but the fxx. We have already calculated what is fx is 3x square minus 3ay, and fy we have calculated is 3y square minus 3ax. So fxx is 6x, fxy will be minus 3a, and t, which is fyy, will be 6y, and you have to calculate what is s square minus rt. S square minus rt at point 0, 0. So this fx at 0, 0 will be 0. fxy at point 0, 0 will be minus 3a, and fyy at 0, 0 will be 0. So that's why this is s is square of that is 9a square minus 0, which is positive. So therefore we can say that 0, 0 is a node. So that completes the proof of this or solution for this example. Let us solve another example, second one. So question is the same. Find the double point for the function x into x square plus y square equal to 6y square. So what is your f of xy here? That let us write down. That is x cube plus xy square minus 6y square. So first I need to calculate what is fx, that is 3x square plus y square, and fy equal to, we have it is 2xy minus 12. Now you have to consider this fx equal to 0 and fy equal to 0. Since fx is equal to 0, 3x square plus y square equal to 0 and 2xy minus 12 equal to 0. 12y equal to 0. So that's why this is 2y is common out. Inside bracket we have x minus 6 equal to 0. So therefore we'll have two solutions. The first one is y equal to 0 or x is equal to 6. So now by substituting that value here, that is y equal to 0. So if y equal to 0, this equation 3x square plus y square equal to 0 gives you 3x square equal to 0. That will imply the x will be 0. And if x is 6, then that will be 3 into 36 plus y square equal to 0. So y square will be minus of 3 into 36, which is negative. So therefore this is not possible. Only possible double point is 0, 0 here, and 0, 0 point lies on this curve. Hence we can write down that 0, 0 is a double point. Now which type of double point is there, that we need to calculate. For that I need to write down, I need to find out what is R. R is nothing but the fxx, and we have already calculated what is fx. Fx is this, fy will be this. So let us write down, that is here fx is 3x square plus y square, fy will be 2xy minus 12y. So fxx is 6x, s is fxy which is 2y, t is fyy which is 2x minus 12. So therefore s square minus rt at the point 0, 0. So r, or I can say fx at 0, 0 is 0, fxy at 0, 0 is also 0, and fyy at the point 0, 0 is minus 12. So that's why this will become 0 minus r is also 0, so that is 0 minus 0 which is 0, and therefore I can say that 0, 0 is the cusp for this curve. Let us solve one more example. The objective of the example is the same for this one, and I am considering this function, that is f of xy equal to x cube plus y cube minus 12x minus 27y plus 70 equal to 0. Now let us calculate what is fx, that is equal to 0, will gives you 3x square minus 12 equal to 0. So that will gives you x square equal to 4, and that will gives you x will be 2 and minus 2. Fy equal to 0 will gives you 3y square minus 27 equal to 0, and that will gives you y square is 9, and that will gives you y is 3 comma minus 3. So therefore the possible double points are 2, 3, 2 minus 3, minus 2, 3, minus 2 minus 3. Is there any other combination is left? 3, y is 3, so it is not possible. Only these 4 possibilities are there. Now from this 4, we will check whether any one of them points are lying on this curve or not. From this you just verify that these points are not on this curve, only the 2, 3 is on that lies on this curve, and that's why what is fxx, if you calculate that is r at the point 2, 3 that we need to calculate, fx is this, so it is 6x, s which is fxy which is 0, and t which is fyy which is 6y. Now at the point s square minus rt at point 2, 3, if you calculate, then it is 6 into 2, that is 12, and 6 into 3, that is 18, and it is minus n because f is what is 0, it is negative. So therefore we can say that this 2, 3 is the isolated, and that completes the solution for this example. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or question, please drop down in the comment box below. See you in the next video. Till then, bye bye.